So first we are going to, okay, before that I wanted to know how many of you already know Verilog coding or Verilog language. Can I know? Can I know in the chat box? Okay, can I know how many of you know Verilog language? Okay, so if you already know the language or if you don't know the language, I'm not going to care about that. I'm going to treat that everyone is new to this particular language. So I'm going to treat you all in that particular way, so that the people who are not having no knowledge of this Verilog also can get 100% benefit. Okay, as you already know, we are going to start from the basic scratch. Okay, like we are going to start with module, gate level modeling, simple gate designs from very basic level to some extent, some good extent with some good project we are going to do. That is my approach. And if you feel like it is too much basic for me in the starting sessions, then you can follow accordingly, like you can follow the recordings or something. But if you join live, it will be interesting for you as well as for me also to continue the sessions, or else it will be like very boring to me. Okay, that is one thing from my side. Yeah. And second thing is, we are going to discuss this Verilog, where 40% will be theoretical part and 60% will be practical part. Okay, practical in the sense we are going to deal most of the part in terms of coding. Okay, obviously Verilog is nothing but it's a coding language, but theory is also somewhat important because we need to know some syntax or some data types. We need to know. Okay, some theoretical part it will be there. And coming to this coding part, what are the tools and what are the tools which we are going to use is, first one, the free for Verilog HDL there is no problem. Free resources are available, like you can use Vivado tool. Okay, why I'm recommending Vivado tool is, after completing this Verilog module, I'm going to start a new module which is known as FPGA programming. Okay, so for that FPGA programming, I'm going to use Xilinx because I have Xilinx board with me. Okay, so I'm going to use that Xilinx board so that we can easily interface our Vivado tool with our Xilinx. Okay, how to generate the bit stream, how we are actually connecting with the hardware, and how we are communicating with the processor, how the communication is establishing with the processor and the FPGA part, and how to create the IPs which are available in Vivado. That and all we are going to explore after completing this after completing this Verilog HDL. That is within a month. I'm expecting like October's after Dasara, like October 3rd or October 5th. I'm expecting to be started. Let's see whether it is going to happen or not. But it's for sure. And after that only, I'm going to start system Verilog. First, I need to. I'm also planning to start FPGA programming also, and that is second part. So that for that we need Vivado tool. If you install Vivado tool, it will be very interesting to work with the Vivado tool. And if you want to work with some Intel related FPGAs, then you should use Quartus Prime. Okay, but I am not going to deal with that. I'm only going to deal with our Vivado tool. Okay, and if you are a person like I don't need any FPGA exposure, or I am not interested in FPGA, then you can simply follow another tool which is known as Model Sim. Okay, so there is one more tool which is known as Model Sim. Or else, if you feel that I don't have any tools in my laptop, or I'm not interested in installing any tools, then you can also explore online tools like EDA Playground, which is also a free tool you can explore. Okay, that is the things which we are going to deal with. And after completing this Verilog HDL, so to the freshers who are actually following me, so we are already having UART protocol running in the parallel, so you can explore in our channel. And Amba AHB protocol also it has been running in the parallel. Okay, and I2C will be uploaded in this month or next month. SPI and all these basic protocols will be uploaded, as well as many are asking about router 1 cross 3 also, but it's a common project everyone is doing. uh, so everyone is asking router 1 cross 3 also. Let's see whether to upload it or not, but after completing Verilog, I'm going to deal one good project. Okay, it will be depending upon the FSM. I'm planning to plan a project on FSM related type only. Okay, it will be interesting. FSM coding will be so much of interesting. Okay, and interfacing and implementing our code on the hardware, so those particular things will be very interesting because our code which we have written, if it is implementing on a hardware, it will give us a very immense pleasure, right? So that is what I'm planning in this particular course. Okay, and the timings will be same, almost 8:30 only, and I'm planning to complete this course in 40 to 50 sessions that I'm planning. Let's see what happens. Yes, so this is from my side. So if you have any doubts or any queries, so basically we are going to start with this Verilog HDL. Okay. So anyone, any idea what do you mean by HDL? HDL, any idea? Full form of HDL? Exactly. So HDL is nothing but hardware description language. Okay. So what do you mean by hardware description language? So basically, we are guiding our hardware, or we are basically describing our hardware. So how our hardware should look like, and what are the type of gates it should have, what is the type of logic our hardware should consist of, and how our hardware should behave. Okay, this and all things we are basically designing with the help of our Verilog HDL language. Okay, now this particular Verilog HDL language, it's a very low level abstraction language where you can actually directly control your hardware, and you can design your hardware. Okay. Can we use C language or C++ for designing our hardware? Any idea, anyone? Can we use C language or C++ or Python? Yes, we can. Okay. So basically nowadays we can also use our C, C++, Python or some other languages. And we can also, what is happening is we can use some tools. That particular tools are known as HLS tools, high level synthesis. Okay. That particular process is known as high level synthesis. So using that particular high level synthesis process, actually your C language, C code is being converted into Verilog code. Okay. That in all things we are not going to deal. We are just going to learn this Verilog HDL language. Okay, and this is introduced in the year 2001. And before this, we have another language which is known as VHDL. Okay, this VHDL is also used nowadays in the defense sector. This VHDL is also used in the defense sector, and it is introduced in some, I think it is around 1999. Okay, and this compared to VHDL and Verilog, these syntaxes look I think 50% similar. Okay, but VHDL is a tightly compact language. There will be more syntax we should follow, and there will be more restrictions compared to Verilog. During the course, I will explain. There will be some particular things I will just give you a glimpse, like what is the exact difference between your VHDL and Verilog. So which is better? And VHDL compared to Verilog, VHDL has more security. Like it's a more highly protected language. Okay, more protection we have in the case of VHDL. So that's why it's still used in the defense. If you apply for any defense companies or any other third party companies which are working for defense, they still use VHDL. They still use VHDL language. Okay, so if you might have also seen some job descriptions also, like they are still expecting VHDL language as a primary skill. Okay, so in that particular cases, VHDL will be useful, and there is no worry. Like if you learn Verilog, then understanding VHDL is not a very big task in my opinion. Okay, or if you already know VHDL, then Verilog is a very easy language. Okay, so this is about your Verilog, and this is about your VHDL. Now, coming to this Verilog, we are basically, this Verilog is a language. Verilog, it's a programming language which is used to model your hardware. And this language, if you want to write it down, you can use a simulator, or you can use a EDA tool. EDA tool, anyone, any idea what do you mean by EDA tool? So basically, EDA stands for Electronic Design Automation. Okay. So using this Electronic Design Automation tools, you can basically develop your code. Like EDA tools, we have Model Sim, Questa Sim, synopsis, cadence. Okay, these are all our EDA tools. Okay, so using this EDA tools, we are going these are basically your tools. Whatever the code which you have written in this EDA tools, these tools are going to map it into the actual gate level netlist. Okay, what is this gate level netlist, how it is going to look like, and what is bit stream. Okay, these and all things which we are going to cover in our course. But our main concern during the earlier stages will be on more about the syntax and how to write the code. This and all things we are going to cover. Okay, this and all things we are going to be concerned. Okay, yes. So this was about your Verilog language, and this is about your EDA tools which you can explore. And EDA tools, if you have access, you can just explore Synopsys tool, and you can also have Cadence tools, Questa, Quartus. Okay, so these and all tools are used for converting your actual Verilog code which you have written into a hardware gate level netlist. That particular process will be taken care by your EDA tools. Okay, so your main concern is to write your Verilog coding such that it will be synthesized. The main task in Verilog language is often people get confused, and often people get lag in this particular concept is synthesizability. So basically, Verilog is a synthesizable language. Verilog is a synthesizable language. What do you mean by synthesizable? So basically, synthesizable in the sense your code, actual code which you have written, will be converted into gate level netlist or hardware. Okay, this will be converted into hardware or gate level netlist. And in Verilog also supports non-synthesizable constructs. Verilog also have non-synthesizable constructs. Non-synthesizable constructs. What do you mean by non-synthesizable constructs? If you use this particular constructs, your code will not be converted into hardware. Your code is not going to be converted into hardware. So Verilog have both synthesizable constructs as well as non-synthesizable constructs. So a developer or a programmer who knows Verilog should be very careful, like what he is coding for, whether he is developing his code so that it should be converted into gate level netlist, or he's developing his code so that he's just writing his code for simulation purpose or for testing purpose. Okay, so he should be very careful. And if you use both synthesizable and non-synthesizable constructs, definitely it is not going to be implemented on any hardware. Okay, so that particular things we are going to focus upon: what is synthesizable constructs and what is non-synthesizable constructs, what should be our approach. Okay, and that are all things we are going to discuss in our particular module. We need to be careful in this synthesizable and non-synthesizable part. Okay, yes. So that was about your introduction to Verilog and EDA tools and synthesizable things and non-synthesizable. These all things we will come across our course also. Okay. Now, so let us see how to start with Verilog coding. So what is the first step we need to know? Okay. So first of all, if you want to develop any Verilog code, okay. First of all, if you want to write any Verilog code, you will write a simple module and end module. So module and end module are basically your keywords. This module and end module are your keywords. Any code, if you want to write, which is to be synthesized or which is just for testing purpose, that should be written inside your module and end module. Okay, the code should be present inside your module and end module. Now, every module is followed by some module name which is known as identifier. Every module is followed by some module name which is known as identifier. Okay, and we have a set of port list. We have a set of port list, and this port list is optional. Basically, this is optional. Why it is optional? Because we will not we can have port list or we cannot have port list in when we are developing our test benches. We actually don't need any port list. Okay, that and all we will see. Okay, and the code which you want to write it down, you can write it down inside between this module and end module. And the module and end module, these are your keywords, and this should be in small letters only. They should not be in capital letters or mix of both capital and small letters. They should be careful, and there is no space between end and module. Okay, so basically these are your keywords. And why I am stressing this much is because a beginner who is basically learning this particular programming language, he is going to make these common mistakes by inserting some space between end and module and by adding capital letters, small letters. Okay, these are all things we should be careful. Okay, for example, if I want to design a simple block diagram like this, which is my design, let's say some B1. My design name is B1. Okay. Now it has some set of input ports and it has some set of output ports. Okay. How to design this in our Verilog? We will simply follow our syntax. What is our syntax? Just simply write down module and module name. Module name, you can write it down anything. Let's say B1. Okay. And we have input port list as A, B, C, X and Y. Okay. So what I can do is I can write A, comma, B, comma, C, comma, X, comma, Y. Okay. And followed by semicolon and end module. And inside this I'm going to give the directions of this A, B and C. Our compiler should know, right, what is the input, what is the input port and what is the output port for our design. Okay, so A, B, C, X and Y are our ports and we should also provide the directions to these ports. How we are going to give the directions to these ports? By simply using the keywords. We have basically three type of keywords: input. This keywords, everything will be in small letters only. Okay, input and output and inout. These are our keywords which we are going to use for giving the directions to our ports. Okay, input is for input ports, output is for our output ports, and inout is for our inout ports. So these are the directions, these are the keywords which we are going to provide for providing the directions for our ports. Okay, now we also have one more term here which is nothing but port. What do you mean by port? Anyone can tell me? So you can see here, your port is actually available to the outside of the module's environment. Okay. And so if you declare any internal signal, that is not accessed outside the module. But if you declare any signal as a port, that can be accessed outside the module. This is the difference between your port and internal signals. Okay. Now, what we are doing basically here, I want to declare this ports as input. So I'm going to use a keyword which is known as input A comma B comma C, and I have output ports. I will simply declare output X comma Y. Okay, and the following code, which is the design behavior, I am going to write it down. This is my input port and output port I am going to declare. Okay, and this is style one of declaring your ports. This is style one. We have one more style also for declaring our ports. Let us see that. So this is style one of declaring our ports, and we have one more style also for declaring our ports. Let's see that, style two. So what is style two? We will simply write down the module followed by module name, followed by when we are declaring our ports itself, we are going to provide the directions to the ports. How to provide the directions with the declaration? Simply write down input A comma B comma C comma output X comma Y. This is how we are also going to provide the directions, and followed by the code which we are going to have, and followed by end module. And there is no semicolon here. Okay, be careful. Here we have the semicolon. Okay, and there should be no semicolons inside our brackets. Okay, so this is how we are going to follow the two styles for declaring our ports for the modules. Okay, these things seems to be very simple and very easy, but these are the common mistakes which a student or a beginner going to make this particular mistakes, and they are going to spend a lot of time for debugging these mistakes. Actually, I have seen many people like in the small mistakes only, they are going to debug it for 1 hour, 2 hour, 3 hours. Okay, but if you are a very medium, or if you are very good, then it's not a big issue for that. But for a very beginner level, these are the common mistakes they are going to spend a lot of time for debugging. Okay, so that's why I'm going from this particular stage. So coming to the rules for identifiers of modules. So when we are declaring module name, module identifier, so this module names must follow some rules. Okay, what is first rule is we should not use number in the first position. Number in first position. For example, one, let's say full adder, one full adder. This is wrong. because you should not use number at the starting position. You can use number at any position, last, first, last, middle, or second position, but you cannot use number at the very first position. You will get the compilation error. Okay. And next rule is we should not have any spaces in the identifier. We should not have spaces in between. For example, full space adder. This is wrong. Okay. We should not have any spaces in between. For example, full space adder. Okay. But we can use underscore. For example, full underscore adder. This is correct. If you want to insert some space, then use underscore. Okay. And you should not use any special characters. Okay. We should not use any special characters. For example, dollar full adder. Okay, this is wrong. Hash full adder. This is wrong. Okay, and you should also not use any keywords like reg, module name as reg, or you cannot use wire. Okay, and module integer. Okay, this and all are your keywords. You cannot use it with your module names. Okay, this is obvious things, but you should be very careful while declaring your module name. Okay, and you can use capital letters, small letters, or whatever letters you wanted to use, alphanumeric letters, anything you can use, but you should be careful in this particular set of rules that we should follow. Okay, so that we will not get any compilation errors. Okay, so these are the rules which we should follow for declaring our module names, and this is how we are going to declare our uh, ports. Okay, input port, output port, in out port, everything we are going to declare. Okay, is it clear? Anyone, any doubts? So the very first type of abstraction level which we are going to have is gate level abstraction, and second one is data flow, and third one is behavioral, and fourth one is switch level. So these are the four type of abstraction levels which we are going to have, which we are going to have in the Verilog coding: gate level, data flow, behavioral, and if we use this three, then it is a hybrid model. Okay. No need to remember all these names. Just this is for reference. So what is this gate level data flow behavior means? Coming to gate level modeling or gate level abstraction, we are going to develop our code in terms of gate level. Like for example, if we have a simple full adder, okay, if we have a simple full adder or full subtractor, then we can actually decide what type of gates should our design should have, whether our design should have NAND gates, or whether our design should have or NOR gates, okay, or whether our design should have AND gates, how our design should look like, what type of gates actually our design should contain. Okay, that and all you can control or you can design using the gate level modeling. As the name itself suggests, you are basically dealing with the gate level. Okay, so you can basically model and you can basically decide what type of gates you need to have. Okay, this is about your gate level. Okay, and coming to this data flow, you are basically dealing how your data should flow. Okay, what type of data should flow and how the data should flow, what is the path your data flow should flow. This and all you are going to decide in the case of data flow modeling. And coming to your behavioral modeling, basically you're not going to concern about the internal structure or what type of gates you should have internally. This and all things you're not concerned about. You are just concerned about the behavior of the particular design, how the design is working. If it is a multiplexer, according to the select line, how your output should have, and if it is a decoder, how your design should work. You're not concerned about what is the internal structure, how the gates are used, whether you are using NAND gates, NOR gates. No, not at all if you are using behavioral modeling. But if you are using gate level modeling, you are concerned with the behavior, as well as you are also concerned with the internal structure, how the gates should be connected and what type of gates you should have. This and all things you are concerned about. This is about your gate level modeling, data flow modeling, and behavioral modeling. And coming to switch level modeling, actually you're going to model in terms of CMOS level, PMOS, NMOS, these and all things you can design using the switch level modeling, but we are not going to discuss about this because we are not going to use this. So we are only concerned about this three type of modelings. One is gate level modeling, data flow modeling, and behavioral modeling. So our entire Verilog will be depending upon these three type of modelings. First, we are going to discuss about gate level modeling. Next, we are going to discuss about data flow modeling, and finally, we are going to discuss about behavioral modeling. Okay. First, we are going to discuss gate level. Next, behavioral. Finally, data flow modeling. That is our main Verilog discussion will be happening. Okay. So how to use this modeling and what are the things which we have in this modeling? What is this? What is this? We are going to discuss. Okay. Any doubts or any queries? Shall we start with our gate level modeling? Great. So before going to start with gate level modeling, we need to understand some more few terms here. So first we need to understand about some basic constructs which is known as comments. Okay. If you want to add comments in your code, what do you mean by comments? Comments are the piece of line which is not compiled by the compiler. Okay. The compiler will skip those particular lines which have been made comments. Okay. So basically there are two type of comments. One is single line comments, that is you can use simple this two obliques, and there is another thing which is known as multiple line comments. Multiple line is nothing but slash star followed by multiple lines of comment followed by star slash. Okay, these comments are used for basically increasing the readability of the code, or if you have written some logic and if you want to help your other colleagues or other friends to understand what you have written, then you will write down in terms of comments, so that the comments are nothing but it is not been compiled by your compiler. Okay, I think these are also available in other languages also, it's obvious. Okay, for the single line comments you will use double slashes, and for multiple line comments you are going to use slash star followed by multiple lines of code followed by star slash. Okay, so this is our single line comment and multiple line comment. Okay, next. So before going to start with gate level modeling, we need to understand some more few terms. One is number specifications. We need to understand, this is a very important topic. How to specify our numbers, we need to understand this. Okay, in our digital also we have started with our numbers systems only. Here also we are going to start with how to actually represent our numbers. So for representing our numbers, there is a standard syntax. First one is size apostrophe followed by base followed by value. This we will pronounce it as tick. Okay, size, tick, base, value. Okay, now what is this size actually representing is, this size is telling you how many bits are present in this value. Okay, this will tell you the number of bits in the value, and this base is nothing but base of your number system. For binary number systems, we are going to use small b, and for octal number systems, we are going to use small o, and for hexadecimal numbers, small h, and for decimal numbers, we are going to use small d, and the value. Okay, this is how we are going to represent any number in Verilog using this standard syntax: size, base, and value. Let us understand this with some examples. Let's say if I want to represent a binary number 1010 base 2 in Verilog. I want to represent this number in Verilog. How to represent? What is the syntax? Syntax is size. Size is nothing but number of bits in the value. How many bits are there? 1, 2, 3, 4. Okay. 4. Tick small b, because it is a binary number followed by value 1010. This is how I am going to represent my number in Verilog. Okay. Now, if I have a let's say next octal number. If I have a octal number, how to represent a octal number? 73 base 8. Can anyone tell me how to what is the answer which we are going to get? 73 to the base 8. How to, what is the answer which we are going to represent in Verilog? You can see the syntax: size, base, value. I want to represent 73 to the base 8 in Verilog. Let's see. So what is the syntax which we have? Size. Size is nothing but number of bits in the value. How many bits are there? These are digits. We have two digits, but these are not bits. Okay, we need to convert 73 into binary. If we convert 73 into binary, how many bits we will have? 6 bits. Each digit is consisting of 3 bit binary. So 3 plus 3, that is total 6 bits we are going to have. So what I'm going to write, 6 tick O 73 is my answer. 6 tick O 73 is my answer. This is how I'm going to write down my value in Verilog. Is it clear? It is nothing but 6 tick O 73. Is it clear? Okay. Now, sir, if we write 8 tick O 73, is it going to give any compilation error? So someone has given 8 tick O 73, right? Is it going to give any compilation error? Or whether it is going to work? If we have written 8 tick O 73, is the compiler going to accept it, or it is going to throw an error? So here there is no problem. There is no compilation error which we are going to get. Okay, no compilation error. Compiler will accept it. Now, how it is going to accept it? Let's see. So what it is going to do is, it is going to allocate the 6 bits which it needs in the binary format, and it is going to append 2 zeros in the MSB. Okay, whatever the value 73, it is going to be converted in binary. It is going to be converted in binary, and it is going to append 2 zeros, so that it is going to make it as a size of 8. Okay, so it is going to make it as a size of 8 bits. Okay, this is what it is going to happen when you write down the size more than which is required. Then it is going to append that many number of zeros. Okay, let's say if you have written 32 tick O73, then also you are not going to get any compilation error. So the last 6 bits will be allocated for the binary equivalent of that particular value, and remaining bits all will be appended with zeros in the MSB. Is it clear? So is it clear? Yes. Okay. But if you are writing, 2 tick O 73, if you are writing 2 tick O 73, okay, let us convert this into binary first. 73 means 011, and this is 111. Okay, this is the binary equivalent. 73 is nothing but 111 followed by 011. Okay, if you are writing 2 tick O73, then also you are not going to get any compilation error. Okay, because I have got this answer in the chat box. So 2 tick O73, you are not going to get any compilation error for this number also. But what is going to happen? Compiler is only going to consider this last 2 bits. So your value will be nothing but, it is nothing but 1 1. That's it. Okay. If you are writing 2 tick or 7 7 3, then only the last 2 bits will be considered. That's it. Okay. Is it clear? Exactly. It will give only 1 1. Exactly. Okay. So you can try these things. Okay. Now, and if you want to represent a decimal number, let's say 15. If you want to represent a decimal number 15, how to represent? Same process. Okay. So you need to mention the, okay, or you can also provide more number of bits you need. Okay, like you can also write 32 tick D15 or 64 tick D15. You can mention anything. Okay, but it will allocate the remaining MSB bits with zeros. It will append the remaining bits with zeros. Okay, that you should be careful. So there is no problem in that, but it will basically consume more amount of memory. That's it. Okay, so there will be memory issues. More number of size will be allocated. That is the reason you should be very careful for allocating this number of sizes. Okay, and coming to hexadecimal, like if you want to represent any hexadecimal number ff base 16, then you can simply write it down as how many bits we need? 8 tick h ff, 8 tick h ff. This is how you are going to represent your hexadecimal numbers. Okay, how to represent your numbers? Is it clear? Any doubts or any queries in this? Shall we move forward? Great. Now let us see some scenarios. Let's say case one. In this case one, what I'm going to do is, I'm going to just represent my number with base and value without providing the size. For example, I'm simply writing tick O32. Tick O32. Now, what will be the size? Can anyone tell me? Or whether I am going to get any compilation error. If I am not providing any, whether I am going to get any compilation error or what will be the size? Yeah, exactly. So if you are not mentioning the size, the default size will be 32 bits. This you should be careful, because if you're not mentioning the size, if you don't know what is the size of the number and if you're leaving it empty, you're not going to get any compilation error, but it is going to provide 32 bits of it is going to provide a size of 32 bits. Okay, so better to provide the size. If you're not providing the size, then it is going to consider it as a 32 bits. Okay, this is case 1. Now let's take case 2. What is our case 2 is, we are not mentioning size and we are not mentioning base also, just we are writing down the value. For example, if I am writing simply 16, then what is my base and what is my size? Can anyone tell me this? Base is decimal and size is 32 bit. So base will be decimal and size is nothing but 32 bit. If you are not writing any base, if you are not mentioning any size, the base will be considered as decimal and the size will be considered as 32 bits. Okay. So if you are simply writing a number, then the number will be considered as a decimal number. If you want to represent it in octal or if you want to represent it in binary, you need to mention the base. Okay. Or if you're not mentioning the base, then it will be considered as a decimal number. Okay. Is it clear? Shall we move forward? Exactly. Base 10 and 32. Exactly. Correct. Okay. Yeah. So that was about your numbers. Okay. That was about your numbers. Now, that's it. So this is about your numbers. This will look like it's a very simple concept, but I will show you some examples where where many of them, many of the new people of this language will do these mistakes, this type of mistakes. I will show you them. Okay. Now, let us see one more concept which is known as strings. So, what do you mean by strings? So, strings are nothing but collection of characters which are enclosed in a double quotes. Okay, I will write down here collection of characters. So, these are nothing but my collection of characters which are enclosed inside my double quotes. This is nothing but my string. Okay, and each character is going to have 8 bits. So, each character is allocated with a size of 8 bits. Okay. So, how many bits the total? What is the total size of the string? Can anyone tell me? What is the total size here? How many bytes of data? How many bytes of memory is allocated for this? Okay. So 1, 2, 3, and I should also consider the space. Okay. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So total 14 bytes of memory is allocated for this. Okay, so this is how I'm going to use my strings. And strings, we have concatenation and string extension. Okay, this and all things we are not going to discuss in Verilog. Okay, we are going to see in the later parts. And in system Verilog also we are going to see, but in this Verilog we are not going to much concern about the strings. Okay, just you need to have some simple knowledge on this. Okay, this was about your all the basic things we need to know for starting the code. Okay, these are the things which we should know. Okay, next from tomorrow we are going to start with the data types. Okay, we are going to see what are the data types which we have: rich, wire, in the net. So in the net, basically we have wire, var, band, supply 0, supply 1. Okay, and integers, real, floating, time. Okay, these are all things which we are going to have. And after completing data types, we are going to see the port connection rules and how to connect different modules. Okay, how to connect the different modules and what are the port connection rules, which we are going to see in our tomorrow session. Okay, and after that, tomorrow is Thursday, and day after tomorrow, that is Friday, we are going to start with the gate level modeling. Gate level modeling introduction, it is of 5 to 10 minutes. That's it. It's a simple coding style. There will be some set of primitives. Just if we know the syntax, then that's it. Gate level modeling will be completed. So after that 10th minute, we are going to start with designing. Like we are going to start with the basic design of half adder, full adder using half adder, ripple carry adder, BCD adder, and we are going to see all the designs which we have discussed in the digital design using only gate level modeling. Okay, using only gate level modeling, we are going to spend our time for 2 days. That is Friday, and if possible, I will take the class on Saturday or Monday. Okay, this is what we are going to deal up to the Monday. Okay, yes.